Calc 12, Chapter 6.1. We're going to look at trigonomic ratios in the standard position. Before we do that, let's recall basic trig. SOHCAHTOA has sine theta equals opposite over hypotenuse, cosine adjacent over hypotenuse, tangent theta is opposite over adjacent. So if we have theta as this angle, we have adjacent, opposite, and hypotenuse. Here's a typical problem. Suppose we have a Ferris wheel. Can we determine the position of a rider at any angle? And can we determine how many times the rider has gone around based on that angle? And that's a loaded question. Of course, the answer is going to be yes. And to make sure that everyone has the same viewpoint, we need to have some conventions. So let's start off by putting the center of the Ferris wheel at the origin. Angles in the standard position start with the initial side along the positive x-axis. So this is the initial side. And it rotates counterclockwise until the terminal side is reached. And this is the terminal side. This counterclockwise rotation is in the positive direction. And we can choose to rotate clockwise or counterclockwise to reach the terminal side. And every time we go all the way around the circle counterclockwise, we add 360 degrees to the angle. So this would be once around the Ferris wheel in the regular direction. Every time we go all the way around the circle clockwise, we subtract 360 degrees from the angle. So this is a new concept for you. Normally we just work with 0 to 180 degrees with SOHCAHTOA. When we go bigger than 180 degrees, we're able to calculate more things. Subtracting 360 from the angles, this would be once around the Ferris wheel in the opposite direction. Anytime we have two angles that have the same terminal side, we say they are coterminal. For example, 30 degrees is coterminal with 390 degrees. 390 minus 360 is 30. And you want to note that every angle has an infinite number of coterminal sides. And we can write this as 30 degrees plus 360 degrees times n. And n being the set of integers. As an exercise, you want to find two more coterminal angles of 30 degrees. And I'll give you a second before I write down some answers. So we can have 30 degrees minus 360 degrees. So this is negative 330 degrees. We can have 30 degrees plus 720 degrees. And that's 750 degrees. So those are two more coterminal angles. Again, you can find different ones. That's just the next one counterclockwise, next one clockwise. We can think of trigonometry as equations on the unit circle. So x squared plus y squared equals 1. This is Pythagoras. With hypotenuse 1. Which also happens to be the radius on the unit circle. And remember, this Greek letter is called theta. If we have this unit circle with trigonometry, sine theta equals the y component. Cos theta equals the x component. And tan theta is simply y over x. Here are some examples. Sine 30 degrees equals 1/2. So that's the y value. Cos 30 degrees equals √3 over 2. That's the x coordinate. And tan 30 equals 1 over √3. Or we can fix the denominator and have √3 over 3. Now we can generalize for any circle with radius r for our trigonometric ratios. We can have sine theta equal y over r, cos theta x over r, and tan theta equal to y over x. And instead of SOHCAHTOA, we have a new mnemonic, and this is Sir Kixertix. And you can see that as sine y over r, cos x over r, tan y over x. So that gives us Sir Kixertix. So how does this help us find the position of the rider? Well, on the unit circle, we can just draw a triangle for the trig ratios. So if we go to 120 degrees, so this, again, this is the terminal side, this is the initial side, and our angle is between those two sides. We have x is equal to cos 120 degrees, and this is -1/2 if you use your calculator. Y is equal to sine 120 degrees, and this is √3 over 2, and you can find that on your calculator. In fact, we can go to other angles, and this is about 240 degrees. So the x value is cos 240 degrees, and y is equal to sine 240 degrees. And you would find this value to be -1/2, and this value to be -√3 over 2. One thing new for you will be reciprocal trig ratios. And this is 1 over sine. So we would have r over y, and this is called cosecant theta. 1 over cosine theta is r over x, and that is called secant theta. 1 over tangent theta is x over y, and that is cotangent theta. So cosecant of 30 degrees is 2 over 1, and that's just 2. Remember, we did sine 30 as 1/2, so we just take the reciprocal. Secant 30 is 2 over √3, and you can fix the denominator by having 2 √3 over 3. And cotangent 30 is √3 over 1, which is simply √3. It's important to note that this notation, sine to the -1 theta, is not the reciprocal of sine theta. Sine to the -1 theta does not mean cosecant theta. It's actually the inverse function. And you've used this on your calculator to find the angle of a ratio. Cosecant is not the angle of a ratio. This is an actual ratio. Okay, we can use Pythagoras or a calculator to compute the 6 trig ratios for any angle in the standard position. This is not one of the nice angles, so you should use your calculator. This is 0.839. This is 0.545. This is 1.540. And you should be testing this out on your calculator. Do not just copy this down. This is 1 over 0.839. This is 1 over 0.545, and this is 1 over 1.540. Notice on your calculator, you do not have cosecant, secant, and cotangent. You have to compute sine, cosine, and tangent, and then take the reciprocal. If you're not getting these values, it is most likely your calculator is in radian mode, so you'll have to go into your calculator and change it to degree mode. And it's important to have a definition. The reference angle is the smallest positive angle that has one side along the x-axis and the other side on the terminal side. And the reference angle is necessary because the calculator will only do inverse trig in 2 quadrants. You have to use a formula to determine the angle in the other quadrants. But let's start with the reference angle. So for 120 degrees, we have to take the terminal arm to the x-axis, the shortest distance. So this is 60 degrees. It's 180 minus 120, so we get 60 degrees. Reference angle. So note, we can calculate the reference angle using formulas. If the terminal arm is in quadrant 1, 2, 3, 4, we use the corresponding formulas. The reference angle will be noted by theta prime, and in quadrant 1 is just equal to theta. In quadrant 2, the reference angle is 180 minus theta. In quadrant 3, the reference angle is theta minus 180, and in quadrant 4, we have 360 degrees minus theta. So in quadrant 3, we have theta minus 180, so that's 240 minus 180, and that's 60 degrees as well. Okay, last page of notes. Determining exact trig ratios using Pythagoras. We have a point, -3, -5. So this is our x value, this is our y value, and it's on the terminal arm using standard positioning. The angle is theta. Determine all 6 ratios. So first of all, we need to calculate the radius. The radius is square root x squared plus y squared. And that is square root -3 squared plus -5 squared. So this is square root 9 plus 25, and that's square root 34. So for sine theta, we have y over r. Y is -5, and r is root 34. Cosine, we have x over r, so that's -3 over root 34. For tangent, we don't need the hypotenuse. This is just y over x, so -5 over -3, and that simplifies to 5 over 3. And cosecant, we can just flip this over, so -root 34 over 5. Flip this one over, -root 34 over 3. And flip this over, we have 3 over 5. Again, on a calculator, you will want to be able to convert a reference angle back to standard position. So theta is equal to theta prime for quadrant 1. In quadrant 2, we have 180 minus theta prime, the reference angle. In quadrant 3, we have 180 plus the reference angle. And in quadrant 4, we have 360 degrees minus the reference angle. So let's look back at the previous example where the point is -3, -5 is on the terminal arm. That's in quadrant 3. Theta prime equals absolute value of inverse sine. We could use any of the trig ratios on the calculator, -5 over root 34. And this is equal to the absolute value of -59 degrees. So theta prime equals 59 degrees. So theta equals 180 plus theta prime. We just use this formula. and that's 180 plus 59. So theta is 239 degrees. One way to check your ratios, whether they have the right sign or not, is to use this mnemonic. All students take calculus. Okay, and this gives you the positive ratios. So in quadrant 1, all ratios are positive. In quadrant 2, only sine is positive. Cosine and tangent are negative. Quadrant 3, tangent is positive. Sine and cosine are negative. In quadrant 4, cosine is positive, while sine and tangent are negative. So all students take calculus. And just to go over the negative ratios again, we have none, we have cos and tan, and we have sine and cos, and we have sine and tan. And remember, these are functions, they take parameters, so really you should have an angle. And that completes this lesson.